Okay, in this video, I'm just going to explain some of the answers to the Le Chatelier's principle lab, where we had the cobalt chloride and we were adding different things and putting different stresses on the system. So here's the reaction right here. All right. It says, what color is a cobalt chloride solution without anything added to it? Well, it was a pink color to start. Um, when we had to add a little hydrochloric acid to it, to get it to a purple color at one point in time, but that was not until the temperature stresses. All right. Question number 2 says, what color did the solution change as hydrochloric acid is added to the system? Well, if hydrochloric acid is added to the system, adding chloride ions, the system is going to shift this way, and it's that blue color. So the second question was blue. Okay. Now the question, because it turned blue, it says, in which direction is the system shifting when HCl was added? Well, if you're adding HCl and it shifts to the blue side, it's going to the products. So our answer is A, towards the products, or AKA to the right. I don't really like saying left or right. I like to say towards the products or towards the reactants. And then, if you remember, we added water to the blue test tube. And when it did, let me go back to this equation here. When I added water to it, it's adding H2O, which was a product. When we added water, it shifted back towards the reactant side. Whatever you're adding, it shifts away from what you're adding. So that is why it went to a lighter pink color. Let me erase some of this for each stress here, okay? So let me go back down to here. This is going to be a quick explanation video. I apologize for any background noise. Color, so when we added to the system, it turned pink. All right. And which direction was the system shifting when water was added? Well, if it went pink, it went to the reactant side. So it shifted towards the reactants, aka to the left. Okay. Now, then we added the ice bath to it. All right. When we cooled it down in the ice bath, it changed to the pink side. All right. So let me cross this off. And we saw this in the video. We cooled it down, it turned pink. In which direction is it shifting when we put it in the ice bath? Well, if it went to the pink side, it went to the reactants. And then the next two questions, what happened when we put it in the hot water bath? When we put it in the hot water bath, it turned very dark blue. Okay? And what direction is it shifting? Well, blue is on the product side. So that's what we have here. Okay? Now, so far, for the most part, everything went normal. Everyone made had most of these right. Now, it's these last two questions that seem to give some people some trouble. It says, based on the results of the last two stresses, the ice bath and the hot water bath, is the reaction endothermic or exothermic? So we want to know, is the heat endothermic on the reactant side, or is the heat on the product side, which would make it exothermic? Now, when we put it in ice, it shifted this way. It turned pink. When we put it in hot water, warm water bath, it shifted towards the product side. Okay? So that's a little indicator. Now, this question is a little bit different because you don't know. We're trying to find out, is it here or is it here? Well, if you remember Le Chatelier's principle, if you lower the temperature, the system will shift towards the heat because it wants to get warmer. shift. Oh, I forgot the T here in shift. Good thing I didn't forget the F. Shift to the heat. So now, if you raise the temperature, it would be the opposite. It would shift away from the heat. So, if when we cool it down, it went to the pink side, and we heated it up, it went to the blue side. Really, this writing should be written over here. Well, that's got to tell us that the heat is on the reactant side, because if you cool it down, it's going to shift towards the heat. If you heat it up, it's going to shift away from the heat. So if the heat is on the reactant side, that's saying that it's endothermic. So this, you were making an assumption, an estimation from it. All right, and this final one we couldn't do in our in my basement lab because I didn't bring home the silver nitrate. So it's another stress we could do on the reaction is to add silver nitrate. Now, if we add silver nitrate, the silver ions in the silver nitrate will react with the chloride ions to form silver chloride, which is a white precipitate that would sink at the bottom of your test tube. So in the test tube, here's the test tube, here's the liquid, you would have a precipitate right down here on the bottom. All right. So, but what's happening is when you form that precipitate, we're using up the chlorine. So we're removing chloride ions. So if we remove chloride, it's going to shift towards whatever side you're removing. So if you remember from the original equation, let me scroll back up here to show you the original equation. If we're removing chloride, there's going to be a lot of extra of the product. So we're going to shift towards the reactant side to produce more chlorine. If it goes to the reactant side, it's going to be pink. And I've done this experiment a few times where if you put silver nitrate in there, the precipitate will form on the bottom, but then you will have a lighter pink solution. So our last question here, it would turn a lighter pink. All right. So I hope that helped you understand some of the answers. Remember your test either on Tuesday, or you'll have a test on Tuesday if you're an A-day class, or Wednesday if you're a B-day class on reaction rates and equilibrium. All right. Good luck. Enjoy your weekend.